In this video, we will talk about dealing with time and dates in Pandas. Pandas was developed in the context of financial modeling, so there is natively a large number of functions that provide different ways to process and deal with time-date values. Now, before we start, let's introduce different conceptual ways of looking at time and dates in Python. We can look at time and dates as stamps, as a specific moments in time. That's the case, for instance, for a specific date time, such as today at this particular hour, particular minute, for instance. We can also look at repeating length of time that occur in between a certain beginning and a certain point. For instance, we can talk about months, we can talk about days, and those are called time periods. And we can also look at the difference or the duration in between two different timestamps, and that's called the time delta or time duration. Now, in Python and in NumPy, there are different ways to store a datetime object. And a datetime object also depends on what we are, the level of granularity that we want to have values within this object. This table shows the different formatting code as well as the associated periods and the different values that we can store depending on if we choose these periods. Under the hood, all of these values are stored at a 64-bit number, but depending on what we want to store with it, we get obviously a different range. For instance, if the level of the granularity is year, we have the largest time span here, compared, for instance, if you want to store at the level of the granularity, which is a day. In most practical application, those level of granularities don't mean anything, except if we really want to store really at that very low level of granularity, which is not applicable in data science application, but it can be the case if we're dealing with some scientific applications. Now, Pandas provides the best of the Python and the NumPy world. Actually, it provides an object called timestamp object that basically wraps around datetime in Python and dateutil in NumPy. That object allows us basically to store and process all different datetime objects uniformly. Let's take a look at this example here. In this example, we are creating a datetime object from this string, 4th of July 2015. Now this datetime object will going to be referred to as date, and you can see here date is a timestamp. Now from this timestamp, we can get access to those different components of that timestamps. And if you type in the datetime object here and dot and invoke code completion, you can see that you've got access to things like the day, day name, day of the week, day of the year. If you scroll in, you've got access to the hour, to the second, to the nanosecond. All of these periods that we've seen before, we have access to. So for instance, if I want to get year here, I can do date.year and it's going to be 2015. It's also possible to provide the string format that we want to get from it. So if you want to get the day of the week, we can do &a, for instance. If I want to get year, I can get %year dash, whatever I want here. So for instance, if I want to format my datetime object using the function string from time, so that's basically converting the datetime object to string, I can pass in here like a formatted string based on the formatting codes here to create my datetime object. Say for instance, I just want year and month, I can say %year, %month, and I can get that here. Okay. Now, beyond those basic operations, Pandas also allows us to index data frame and series using time and datetime object. And we get what we call a datetime index. In this example here, we are manually creating a series in which it has the values 0, 1, 2, 3, but the index itself is a datetime index. So basically we're converting this list of values to datetime objects and creating a datetime index. Now it shows very much like a series. If we don't use this datetime index, we're going to actually see something very similar here. We're going almost to see the same series. But that's deceiving because in this case we have an index which is a string. So for instance, if we slice the string, we can get a slice from, for instance, 2014 704 to 2015 704, right? But if I try to index at 2015, I'm gonna get an error here because 2015 is not part of the index. However, if I create my index to be a datetime index, it's a different story because pandas will understand that since it's a datetime index, I'm interested in the year, so it's going to give me the subset, which is the year 2015. Now we can create a datetime index for timestamps, time periods, and also for time deltas. Let's take a look at this example here. Here I'm creating the datetime index from a bunch of dates. Some of these dates are string values, some of these dates are Python dates, and you can see here that this function toDateTime is very similar to the function toNumeric. It basically converts everything to datetime regardless of what you pass to it. So this is a very handy function if I want to convert values which are string or other kind of date values to datetime objects in pandas. Once I do that, I can convert it to period here. So I can say, okay, I want to convert it to period, and my period here is day. So basically that's going to give me a period index. And you can see that it's similar to the datetime index, but it's basically saying it's a period. I can do it on a monthly basis, and you can see here I get the month instead of the days here, so on and so forth. So I can choose the periodicity of the datetime objects I want when I create a period index. Now, if I take the difference in between two dates or a date and all the days, I get a time delta index. Let's take a look here at this example here. Dates is basically the datetime index. If I take date 1 minus dates 0, I'm going to get a time delta because there is 1 day difference in between dates 1 and date 0. What I've done here, I've done dates minus date 0, so basically Pandas is going to broadcast this operation, and I get the difference in between each one of these values and the first one, and I get a time delta index here. Okay. Let's take a look at this function, dateRange. dateRange basically creates a datetime index from a range so that I don't type in all of the values. So you can think about this as the function range that creates a range of integers, but this one creates ranges based on dates. So in order to create a range is basically to create the range by putting a beginning, a start, and the end. And by default, I'm going to get one at the level of granularity of each one of these objects, which is day. So I get a range between each day between the 3rd and the 10th of July 2015. Alternatively, I can provide the number of periods here. I can also provide the number of periods, and I can also provide the frequency. So basically here I'm going to say, well, start from this date, give me 8 periods at the frequency of hours. So I'm going to start from hour 0, and then it's going to give me 8 periods, increasing each one per hour. Here's another example. Give me 8 months starting from July 2015. Here's another example, but this one is using time delta range. Instead of giving me a time index or a period range, is giving me a time delta range. So give me deltas starting from 0 to 10 frequency of hours. So I get a delta of 0 hour, a delta of 1 hour, a delta of 2 hours, and so on. So you can see that the frequency here is very useful because it allows us to specify the frequency of the deltas, the periods, the timestamps that we're getting. In addition to the basic frequencies that we have access to, pandas also have more frequencies that provides more features, especially when it comes to business calendar. So for instance, we have a calendar day, we have weekly, we have month end, we have business month end, quarter end, business quarter end, and so on and so forth. So in addition to the ones that already exist in Python, we've got access to the business related time periods here, which are very useful if we are dealing with any financial or organizational application. Let's take a look at this example here. This is using period with B, business day. So give me 5 business days starting from the 1st of July 2015. And here you get the 1st, the 2nd, the 3rd. Presumably the 4th and the 5th are weekend, and we can check. I'm pretty sure they're weekend. So we go to the 6th and the 7th. Right? If we've done this on a daily basis, on a calendar day, we will get a weekend in between. And we don't want the weekend, we want the business day, so we do B here to get a business day. Similarly, for all of them, we can get the end of the period rather than the beginning of the period. So by default, they will give us the start, for instance. They will give us the end of the period, but we can affect the suffix s to indicate the start. For instance, if I want the month start, if I want the quarter start, the business month start, and so on and so forth. We can also create our own periods by combining the existing ones. For instance, we can create any quarter based on any month, for instance, or any business quarter based on any month, starting from any month. This gives us maximum flexibility when we are dealing with times and dates in pandas. For instance, in this example, I'm creating a time delta range from 0, 9 periods, but I want the frequency to be 2 hours and 30 minutes each. So we get 2 hours and 30 minutes when we step from each period to the other period. Now, in addition to all of these functions, creating timestamps, time periods, and time durations, we also have access to functions that allow us to process these values once created. There are 3 types of functions: resampling, shifting, and windowing functions. So what we're going to do, we're going to see these functions applied in the context of some real financial data. So what we do here, we basically installing a package called Data Reader, and we're basically reading data about stocks of Google starting from 2004 to 2016. So what do you have in this example? We have the high, low, open, close, volume, and the adjustment close of the stock at each one of these days. We're going to focus on one series, which is the close value here. We're not going to worry about the remaining ones. Let's plot this series. So we're going to plot it, and when we plot it, you can see that the value of the stock here is plotted, and it's been increasing over time with some fluctuations. Okay, here is the plot. Now you can see here that because we have a very detailed data here, there are many fluctuations in the stock value of Google. And those fluctuations are, daily, weekly, monthly. There are fluctuations at different levels of granularities here. If we're not interested in working with so much granular data, we can basically resample this data. Resample, basically, you're trying to aggregate this data to a different frequency. There are 2 ways of doing this, either resampling or just using a function called asFrequency. The difference is that resampling is an aggregation function. It basically averages out values to get them to a different level of granularity. asFrequency is a selection function. It basically selects one of the values at the higher granularity as a representative. So let's take a look at resampling. So I'm resampling at a business year here, BA, and I'm going to do the average here. Notice that if we don't do the average here, we just get a resampler, kind of like a group by object that we have seen. We have to apply an aggregation function here to get to the mean, to get to the median. It's up to us, right? We need to specify how we're aggregating it. So this is kind of like group by, but group by what? Group by the values in each year, and more specifically in each business year. So we can do one of the aggregation functions. Let's keep using the mean here. As frequency, on the other hand, is just selecting one of the values here as representative of the whole aggregate unit, which is a year here. So as frequency BA is going to select the value at the end of the year as representative of that year. That's what we get here. Now we're going to plot both of them. We're going to plot the original series, the resampling, and also the as frequency one. And they show in a plot like this one. So you can see the original one is very kind of fluctuating. The average one, which is the dotted one, is smoothed, and it's smoothed because it's taking the average of all of these values in each year. The as frequency one is very jaggy because it's just picking on one value as a representative value of the unit, of the new unit, which is the new year. We can do both upsampling and downsampling. So for instance, in this example here, I'm going to upsample to a daily basis. I mean, this is interesting here because we don't have data on the weekends, so we get null values. So we can do something similar to what we had when we had null values. We can do fill NA, and we can fill NA using different types here. So for both of them, we can either upsample or downsample. Here is an example of plotting the original series and plotting the upsample of that series. And you can see here when we upsample, we have gaps here. So if we fill using backward fill, we're going to fill the gaps with the previous values. If we fill with the forward fill, we're going to fill the gaps with the previous values, and the backfill with the next values, with the subsequent values. The second operation is called time shifting. So in time shifting, we basically want to push time backward or forward by a certain value. So let's take a look at this example here. If we do as frequency D, that's basically upsampling to a daily basis, and we get the weekends as nulls here. If we want to look at future values, or for instance, in general, we want to have the difference between current values and future value of previous values, we need to shift the data. There are two ways of shifting. There is shifting the data itself using the function shift, and shifting the index itself using time shift, t-shift. Let's take a look at this example here. If I t-shift by 10, what I'm going to get in here, I'm going to get each one of the values of the index pushed by 10 days. Meaning the value 49.98, instead of being associated with the 19th of August, it's going to be associated with the value of 29th of August. I can do shift here. I can do shift the values itself. However, if I shift the value by 10, I'm pushing the values forward. Right, so I'm pushing the values forward here, and hence the value here in the 29th of August is now 49.98, and I'm filling all of these values with with null values. Let's take a look at this plot here. We're basically plotting the original series here, and we're plotting a shift of this series using the both function shift and t-shift. You can see that the plots show the conceptual difference in between these operations. When I did shift the values, I kind of pushed the whole line, the whole graph to the right. So the value here associated with this point in here is basically, so 900, that's almost 3 years of time. It's kind of this value here at the beginning of the axis. However, when I shifted the index, the series itself is the same, except that the labels on the axis have differed. Let's take a look at this example here. Here I want to see the return of in investment in the data in each year. So for each year, I look at the future value of the stock by shifting the index backward, meaning I'm looking at the future value, and I'm dividing it over the original value. Once again, this is a division over 2 series, so Pandas is going to align and perform the division operation. So I'm going to get a series here. If I plot the series, I can see that in almost all of the year, except around the .com, around the crash in 2008, not the .com, the crash in 2008, the return of investment was positive, meaning if I invest in Google in the next year, I'm going to get some return of my investment in the Google stock. That was not the case in 2008 and it went almost zero 2010 to 12. So there is some fluctuations here. Once again, to kind of see what's going here under the hood, we can take a look at the series here, Google here, right? If I shift this T-shift minus 365, T-shift here, so I need to store it as a frequency of D, which is the step I forget to run in the past, or I can just chain these operations here so that do not damage the code here. Okay, so if I don't do the T-shift, that's the original series, and you can see here that this value 49 is the value associated with 2004. However, if I do shift, you can see that it's now the value associated with 2003, meaning it's the future value of the stock in a year, right? So what I'm doing here, I'm just calculating the difference in between the future value of the stock and its current value. That's what I'm basically doing here. And because the index, Pandas will align the index, I'm going to get a difference here. The difference will be not a number for many of these, but it will be a number for the remaining ones. Let's do that here. And that will give me an idea about the difference in between the stock's current value and the stock future value. This difference is basically the return of investment. It's just normalized across the value here, which I'm plotting here. Okay, so let's take a look at this final set of operations called rolling window operations. In those operations, we would like basically to smooth a time series by taking into account what we call a window. That's basically time before and or time after a certain time period here. That's called the rolling window. So if I take a look at a rolling window of 3 days, I'm basically looking at 1 day before and 1 day after. So say for instance I'm looking at temperatures. If I average using a rolling window of 1 day, 1 plus and minus 1 day, for each point I'm going to replace it with the average of the current point plus the point 1 day before plus the point 1 day after, and I'm going to do the average. That basically smoothes the time series, as we see here in this example here. So it's very similar to resampling, but we're not resampling here. We're basically looking at a local of observations before and after the current observation.